家嚟到呢個Verter 呢個 presentation 啦，咁咧就Tourage 咧就係我哋代理之後嘅第一次嚟香港，咁佢呢個牌子咧就好得意嘅，我就想問下佢咧，究竟呢個 logo 咧係代表咩啦 ？Verter 係咩意思啦 ？So Tourage, I just want to know what is the meaning of Verter and your logo stand for.
Okay, the Verter in Latin means a point of change. For example, you thought the earth was flat, but then you find out that it's round.
Okay.
Yeah, that's a point of change. Like you
Okay.
don't fly, but you find out how to
Yeah.
make an aeroplane, and then you fly. And the original part of the logo, if you remember, it had a line and a little square. The full logo has got a little line here and a little square.
Okay.
That means the square is what is, and then this side is Verter, which is multi-layer, multicolor. So the world as is, and the world with Verter.
Okay. So what is Verter stand for? Name.
The change is a point of change. It means a point of change, change of direction.
Okay. So you have a slogan, running the groove, right?
Running the Groove is a tour we're doing with our retailers.
Okay.
And visiting like Radar, like we had in Singapore and Japan, you know.
And you are the runner. Okay.
I'm the one who runs.
So this is your turn.
Thank you. Thank you.
Thank you.
Hi, everybody, and thank you very much for coming over. And I suppose after lunch I better play some lullaby music so we can all go to sleep. But unfortunately, we're not going to do that. What I thought I'd do is just briefly give you a little bit of background to Verter and myself, just in case you're not familiar with the company. And then doing some explanation of why Verter does what it does and why we do it the way we go on about design and manufacture and demonstrations, etc. I am Touraj Moghaddam. I started in the audio industry when I was at the back end of my research at university with a product that started a company called Roxan, and that was in 1985, June 1985. Around 2006, between 2006 and 2008, I departed from my previous company and began a new adventure, which ended up being Verter. It was more to do with understanding the weak links in systems. So before you go and keep improving everything, you first identify the weak link, you get that corrected so that your window becomes bigger, and then that will show you the next weak link, and so on. Audio replay, not audio which we know, like for example in a studio. Audio replay's job is very specific. If you compare, for example, what happens in a studio and what happens with an artist, they create what they want to communicate with us. And when they're creating this, they may want to change all sorts of things. They may pick up a very well-tuned guitar and say, no, I want to tune it quarter tone down, because that's how I like the sound. Or I have a piano, but I don't want to play on this piano. I want to play on a mini grand. I want to play on an upright. I want to play on a Steinway. I want a Bosendorfer, Bechstein, whatever they choose. Drums. You can have different skins on the drum, different bodies on the drum, the cymbals. One person will go for Zildjian, another one will go for Pasty. But that is the choice that they are making. They're making that choice because they want to give you a story. They want to show you their art. It's just like an artist painting. They choose the pigments and the colors that they like. They want to paint like this. Once they've done this and they put it on, say, a piece of plastic called an LP, our job is not to change what they've done. Our job is to give you an exact copy of what they did. So if, for example, you have a beautiful painting from somebody, obviously not everybody can buy the painting and have at home, but you can buy a nice print from the painting. Now, this is like our job. The print should look like the painting. When you look at the print, you look at the painting and say, oh, that's a good print. I frame it, I put it at home. Now, it doesn't matter if I like blue, yellow, orange, you know, there's no, if that painting was orange relative to what it's supposed to be, then the print is not a good print. Now, if you want to change the sound that you have, it's very easily done. You buy a very nice linearizer and you can change whatever you want. But you are changing what you want to change. If I change something here, then I will change for everything you're listening to. And that is not what we're about. So with Vetter, my main mission was try to get as close as possible to the actual source. And we have been very fortunate. Because I have quite a good contacts in, for example, studios, or whether they're artists, or whether they're cutting engineers or mastering engineers. And with these people, we can actually get the original source and then the record that we have produced from the source and play back the two of them to make sure that we are doing our job correctly. And we have done these demonstrations. I did a little bit in Singapore when I was before. I had actually the exact signal that was going to the cutting lathe that made the lacquer, and I played the LP, and I played the signal that went to the lacquer, and you could switch between the two. Even on a DG1, the difference is absolutely marginal. And for us, this is very important, because I don't want to choose what you listen to. You choose what you want to listen to. If I make something that you play, I don't know, jazz, you say, oh, that's really good, but you put hard rock or metal and you think, whoa, this is not right, then this is not doing its job correctly. So what I will do is I'll start with the DG1. I'll play a track just to give you a flavor of, for example, what a DG1 does. And this is the basic DG1. This has got the magneto cartridge on it, and we're not using a Technomat, and we're not using the Challenger. So this is almost like the very basic DG1S that you get. From here, we are going into the Phono 1, which some of you may know. If you don't, this is the phono stage that Vetter makes. It's not a statement phono stage, but it is a very, very competent phono stage. Again, this doesn't change what the original source is. It tries to stay true, not just from frequency response, but also from dynamic range, resolution, and also spatial information. Because when a mixing engineer and a mastering engineer work with the track, they try to, for example, if you record multi-track and you're putting all of them together, and the mastering engineer's job is to understand the music, a good mastering engineer, to understand the music and then say, okay, there is a little hi-hat, but it's too close to something else. So it just separates the things a little bit so that you can listen to every single instrument, every single voice that is there, if it's a chorus or something like this, so you can understand the music the way the artist wanted you to understand. And the good artists actually sit with the mastering engineers, listening to the final master thing. They say, that's fine, you can use this, and then the next track, the next track, the next track, and then they make the album. So by playing a piece of music on the DG, what I like you to do is don't think of it as a technical piece of engineering. Think of it as a performance. If the performance is good, are the musicians playing together? Are they playing off of each other? Or is it like one person is sort of reading the notes this way, another one reading the notes? They don't really gel together, yeah? Because you can be sure a good piece of music, when it's done in the studio, it definitely does gel together. And then what I will do next is that we play a little bit on the DG, a little bit on the SG, and we go to the RG, and I will explain a little bit about the differences, but I leave the questions to you. So after we've done, any questions you have, you want to know more about a specific part or item or a product, if I can answer, I'll do my best. And also, before we start, I will just tell you that we've got a DG Phono 1, and this is going through the Gryphon preamp, power amp into the Magicos. The cabling currently, a lot of it is Vetter. There are some other cables, and we got also the Pulse XS going into the Magicos here. You may have noticed we have a distribution block. Just to cover this a little bit, the mains distribution block is not an active component. It has some information that it gives you for the mains. For example, it tells you if the incoming phase is correct or not. Or sometimes, actually, you may have what we call a split mains, is that you get, say, 100 volts on live and 100 volts on neutral. So it's not like ground and 200 volts, for example. It gives you some information about the frequency, the voltage, the current you're drawing. But most importantly, from a setup point of view, it's like a tool. And I will show you afterwards that you will see some of the equipment that we have connected to that. You have ability to change the incoming phase. This is not a signal phase. This is a live and neutral. So if you imagine you had a 2-pin to the wall, you can plug in like that, or you can plug in like this. Why we do this is because when you have many components connected to each other, they can generate kind of voltage that it's not in the mains, but it goes onto the ground and the chassis and so on. Maybe in the past you have encountered you're connecting some screen or something and you touch the RCA audio connector, actually gives you a little shock. That's because there's a very high voltage on the chassis, for example. It's not very high current, but if all the equipment voltages are normalized, then the system will always sound better. Now, if you're interested in this, we can do some demonstrations afterwards just to see what the effects are. But before going any further, there's the DG1S, and I've chosen a track from this compilation. It's you have several vocals on there, and you also have some instruments.
You may be an ambassador, but you're gonna have to serve somebody.
The reason I chose that track is you have a lot of vocals with a lot of dynamic range in the vocal, but it's on the last track on the record.
Yeah.
Just to show that, for example, female vocals going up, you have no distortion whatsoever. Many of you're familiar with when the playback of vinyl gets towards the center of the record, normally your distortion keeps increasing. A lot of the times this is attributed to the angular error that the tone arm has. But it is not the case, because in fact, on the beginning of the record, a pivoted tone arm has a higher angular error than it has at the end of the record. The biggest problem you have as you approach the center of the platter is you run out of real estate. And that is what causes the problem for most tone arms and most record players, not the angular problem. Let me explain. When you are cutting the lacquer, say for example you have a tambourine and it's got a frequency up to 16K, for example. That means the little needle on the cutter that is cutting the lacquer, and there's like a thin string of swarf that comes out, and they pick it up with a vacuum to take it away from what is being cut. That cutter is going sideways 16,000 times a second. It requires approximately 600 watts to cut the lacquer. 600 watts. Otherwise, it can't get the proper impression on there. Now, if you imagine on the outside of the record, say a distance like this, and I am cutting 16,000 cycles per second, as I move towards the center, you see how much smaller that gets. So within that period, I've got to do that 16,000 times. That is what causes the problem. And you have to imagine the diamond, the tip, is not tracking the groove. We call it tracking, but it's not actually tracking. If I give you an analogy, if you're tracking a road in a car, you're driving the car and you're active with the road. So you see a bend come and you correct where the car is going. So you're tracking this circuit. Now imagine what happens there. is like you pick the car up, you hang it over the road, and then the road comes at 100 miles an hour under you. You become reactive. That means that the groove comes, hits the diamond like that, and the diamond needs to go where the groove is telling it to go. It's a little bit more difficult to control. So all the things about the tone arm, the stability of the tone arm, the dynamic response of the tone arm, the bearing structure, how does the bearing move sideways, side to side, what is the stiction, what is the friction, what's the noise signature in a bearing. I mean, if you look at, for example, a tone arm with ball races in the bearing, when you're moving up and down, you can't hear anything. But this is no different to like a bicycle wheel. If you take the same ball race and you spin it, it will make a whizzing sound. That is the noise signature of that bearing. And every time it wants to move, the balls are actually sliding. Nothing is rolling. So all of these things affect the diamond that is here. Ideally, you want the tone arm to be completely the slave of the diamond up to about 6, 7, 8 hertz. Why? Because record moves in and out about half a hertz, and it goes up and down about 5, 6 hertz. So the arm needs to move up and down with the groove and go sideways with the groove up to about 7, 8 hertz. By the time you get to about 10, 12 hertz, where music can begin, then this needs to stay stationary and this move. So it's a bit of a contradiction in what the tone arm needs to do. So you have to be totally flexible up to this point and then become completely rigid above this point. And that is why a well-designed tone arm, well-designed drive mechanism will give you much better results without all these distortions, without all these problems. And on top of that, if it is doing its job correctly, you hear more of the music. Most of the time, people come and listen to our records and say, wow, they're really quiet. No, it's not the turntable that is quiet. The noise you hear from the vinyl most of the time is when the groove is going, the diamond is slightly sliding, slightly skating. And therefore, the record will wear more, your tip will wear more, and you get more noise. It's like a car. If the car slides on the road, you have more tire wear. You have to change your tires more often. If you're not skidding, your tire will last longer. So that's a similar analogy there. Now, I want to play something very different to what we just heard, again on the DG for you. And this is to do with the transient behavior. On the other one, believe it or not, we had very high dynamic range, but it was more to do with the vocal area. When you're listening to things like bass guitars being slapped and plucked and guitars being plucked, you have from low frequency to high frequency that is going up and down in dynamic range. And vinyl should have seriously high dynamic range. And the reason I say it should have seriously high dynamic range, many people think that, for example, when the CD came out, everybody was saying CD has got 120 dB dynamic range. It doesn't. What it is that they're telling you what is the silent and what is the highest level you can get. But that's not musical dynamic range. Musical dynamic range is when you have something at a high level, what is the lowest level you can hear at the same time without it being distorted or sort of blocked by the high level. That is true dynamic range. It's like speed stability. There's no point having one frequency and checking that frequency and say, oh, that's very stable. But no music is just one tone. Music has got so many different frequencies with totally different levels, all being played at the same time. Now, the effect of these things on each other will give your brain the perceived pitch. So you may measure two record players, for example, having exactly the same speed stability, but one of them, when you play the piano sounds much more real than on the other one. And the reason for that is piano pitch is a hammer. It's actually a percussive instrument. It's like a drum. So whether I push the button or you push the button, the key that is being pressed, it will hit the same way on the string. And if your brain is very clever, you actually know that this is a real piano being played. So if you're, for example, in a pub, and in the background somebody has got a little piano and they're playing through the PA system, you immediately know this is live. You never say they have got a very good hi-fi system. And if it is actually recorded, even with the best hi-fi system, you say, oh, they're playing nice music. You never say there's somebody playing a piano. Yeah. So I'm playing a track from Antonio Forcione's quartet. This is a live track, and it's actually just him. It's not the quartet, so it's just one guitar playing. I hope that this sort of gives an indication of, for example, why we decided to do the DG1 or the Phono 1. Because even in the context of this system, you won't think you're handicapped. Do you know what I mean? It doesn't matter. I can play an orchestra on this. I can play a piano piece. I can play choral. I can play blues, jazz, rock. In fact, at some point, I'm going to be playing some special acetates on the RG1. Maybe we'll play one of them on this. I wouldn't play my acetates on any other record player, anywhere, because they just wear. I mean, acetate is effectively a disc of aluminium with almost like dry paint on it. It's the same as a lacquer, only smaller. So when you're doing a test cut, just to see whether the settings on the lathe are correct, you cut on an acetate, and you'll play back. Most of the time, they can play back so many times. Yeah, I've got acetates here that I've played hundreds of times. And I mean hundreds of times. Yes, you get clicks and pops, but that's because every time you take the acetate out, every time you put it like a record, there's always a little dust particle or something that goes in there. But I don't lose low frequency, I don't lose high frequency, I don't lose anything. And it doesn't sound like it's worn, yeah? But it's the closest thing you're ever gonna get to the master. So we just played something quite demanding on a system from our most entry-level cartridge moving magnet, and all of it is going through the Phono 1. What I'm going to do now is I'm going to play a very short piece, a beginning of a track on DG1, because after that I want to go to the SG. So we play a little bit of that, and then we go to the SG. what happens with our products, you should never look at the products being upgraded up, because I never design like that. I always design what I can do at the top, and then I scratch my head thinking, okay, which bit can I take away so that you don't lose too much, but you pay a lot less? And then the next one, and then the next one. So this actually is a derivative of an MG, which unfortunately we can't play. We don't have enough connectivity here. And this is a derivative of SG, and the SG is direct derivative of the RG. And this tone arm was the first product outside of the cabling that Vetter did. And the reason for this was it was the weakest link in the system. I knew from Roxanne days that any changes to the tone arm made the biggest impact on the performance, whereas I could change lots of things on the TMS, change the setting a bit, and the performance will change a little bit. I changed tiny amount on the Artemis, and the performance would jump up and down like a yo-yo. So this was done first in order to give me the support that that cartridge needs, and then the record player was designed, the turntable was designed. And in the turntable, believe it or not, the most important component of the turntable is actually your motor. The motor is the one source of energy. All the music you hear comes from the motor. And when I say motor is the most important, it doesn't mean the bearing is not important. It doesn't mean the platter is not important. It doesn't mean the suspension and things. Everything is a chain. So if you have a weak link somewhere, the chain is going to break. But the reason I say it's the most important is that because all the music you hear comes from the motor. It's almost like a loudspeaker, the turntable. And the motor is the amp. So it doesn't matter how good this loudspeaker, if the drive for the system is not good, you won't get a good result. And that is why, even if you go back to 1985, the Xerxes had an outboard motor drive. Because that was something that I thought, okay, what if we become cleverer? We can make a better drive. If it is inside, what can I do? Nothing. If it is outside, I just change it, put another one in, you know. Of course, I would love to design my own motor so that it runs even smoother. But even with a good quality synchronous motor, we have the ability to drive it very, very smoothly, all the way to very badly. And we need to be at that point. And with the RG, few years later, we brought the reference motor drive. And the reason I'm talking a little bit about this is because I just want to tell you the same as that this is a derivative of that, that is a derivative of this. Imperium is a derivative of the reference motor drive, and we've got somewhere here, we've got a tempo, which is a derivative of that. And hidden inside here is actually a motor drive, which is based on this. If we hadn't done those, there was no way we could make this for this price. All the research and development for this new generation of motor drives was already spent on this. And the way it works is that in the past, we used to have a crystal. And this crystal gives you a square wave. and you filter the crystal to get a sine wave, and you integrate it, you get a sine and a cosine wave, and the phase angle will give you the direction, and it will drive this synchronous motor. And for years I was trying to improve this by having better crystals, much precisely cut, the ppm lower, power supplies better, everything. Every time we spent lots of money, the performance was increased only a small amount, not a huge amount. Until one day, one of the engineers who actually is not really so much an analog engineer, he said, because I told him what my problem was. With a square wave, your top half and the bottom half, they're not necessarily the same. Which means when you filter it, you don't have a perfect symmetrical wave. Although the distortion is low, you don't have harmonics on there, but the shape is not quite exact. And every motor is sort of jumps between the poles, and is how it goes from one pole to the next through the shape of the wave that is actually critical. So we decided we generate the waveform in the digital domain. So you have a microprocessor that gives you, say, a 50 hertz sine wave, but it's digital. It's like a fax machine. So you need to translate it into an analog. So you have a DA converter inside that changes this to an analog sine wave. And then it goes through the amplification, etc., etc. And because of that, we get a very, very symmetrical waveform. So the drive in here is actually based on the top of the range. And also, we use exactly the same motor on all the record players because it is so important to have the good. So we don't compromise on the motor here. So all the compromises here are platter is much cheaper to make, chassis is much cheaper to make. So everything that is only for stability, but it can be achieved at a lower cost, we do. What needs to be uncompromised effectively, we leave it uncompromised. So before going further, I'll play you a little, I'll play you a little piece from this Hugh Laurie, Let Them Talk. It's called St. James's Infirmary. You will know the song, but it's a different version of it. And by the way, this is Hugh Laurie. This is the chap in House, the actor, comedian, and he plays piano and he sings. So I hope when we first started, you heard it just sounds more real. You know, the piano sounds more like a piano. The bass line, when it comes, sounds more like actually a string being plucked. But we're not tampering with the musicality or the timing or the actual structure of the whole thing. But one of the qualities that you get from jumping from, say, the DG to an MG or an SG, using the SG tone arm and then this drive system, which is more elaborate than that drive system, is you get much better harmonic structure of everything. The reason the piano sounds a bit more real is because it actually does sound more like a piano. The reason the bass line sounds more real is because it does sound like that. Now, the next track I want to play on this, again, you will know the music, all of you, but it is a totally different version of playing it. But what I like about that track is that the guitar player has put the kind of distortion, the sound that it likes from his electric guitar. The keyboard has got that sort of almost like a Hammond organ Moogie type sound to it. And the same goes with the drums, etc. And even the horn that comes at the beginning, it has so much texture in it that you almost feel that it's real. It's actually the sound of the guitar is coming from the amp that they actually used, rather than plug into the desk and play it. Do you know what I meant about the guitar having that little distortion? It's almost like somebody's got a little amplifier, they put the distortion on and they're playing. The same goes with the keyboard. Of course, the sax is very closely mic'd, so it's a little bit different to see. But it is lovely to be in a position where you can actually hear all the little things that they've done to make a particular version of a sound for you. And that is what the artists do. Each one has got their own unique sort of sound that they get from their guitars, or they get from their keyboards, or they get from the drums, and so on. Before going to the RG, I want to go back to the Antonio Forcioni, because even on the DG, it was like, wow, you know, there's so much dynamics, so much this, that, the other. Can you actually make it better? So we're going to play it on this. And once we have listened to a little bit on this, we won't play the whole lot, and then we just jump straight onto the RG. See what happens when the platform, the tone arm gets better, and the motor drive, etc. And you'll see the same as like with Hugh Laurie, you're getting the same sort of change. It's not that there's something sort of wrong on DG, it's that it becomes more real when you go to the SG. One thing we need to realize, no component in a hi-fi system actually improves anything. It's impossible to improve the signal. All they do, they damage it. They color it, they destroy it, they take away from it. The best hi-fi is the one who's got the best damage control, if you know what I mean. It's not that it's improved on this or that. It's just that it damaged the signal less. So here, we're just doing less damage than we did on this one.
Yes, that's right.
Now the difference between the RG1 and the SG1 is actually nothing to do with the structure of the record player. The entire geometry, structure of the plens, all the decouplings, etc., motor assembly, even the bearing housing is identical between the SG and the RG. The real difference is between the spindle, the ball, and the platter itself. They look similar, but believe it or not, that platter costs more than 4 times to manufacture than this one, and the spindle costs at least 12 times more to manufacture than that spindle. This was made first. So I was quite happy with what it was doing, but then I wasn't thinking about the MG at the time. I thought, okay, not everybody can put this tone arm on there. What if they wanted to put a lesser tone arm? So do you really need all of this platter and bearing assembly? So we just made it from 1 piece rather than 2 pieces, and the tungsten carbide silicon nitride changed to hardened stainless with a tungsten carbide ball. The reference tone arm is very different in construction to the SG. SG is trying to mimic what this does, but almost at a tenth of the price. So you can't blame it. You know, this was done without any thought about, oh, this is too difficult to assemble, or it's too difficult to machine, or something like that. We just thought, okay, we make it, we put it together. Either the idea of tone arm being the weakest link is correct or is not correct. And lucky enough, it proved to be correct. So I'll play the same. I hope you heard it was almost like there are more strings on that guitar, but they're not. Whether you play on a DG or an SG or an RG, the actual content in the groove is not changing. The reason it sounds like there's more information about how the strings are played, partly is to do with the dynamic range, partly is to do with the noise, the background noise, and is partly to do with the harmonic structure, but also is to do with the response of the system. If you remember what we talked about, this road coming under you at 100 miles an hour, and the car is being thrown about, the same with the cartridge, the less is thrown about, the more is the gap between one note and the next one. So instead of one note going like that and overlapping with another one, as this one goes like that and the other one goes like this, you hear more distinct the two sounds. So that's why when you're listening to that guitar, especially even when it's just hitting the entire strings together, you can actually hear the structure of each string much more clearly. And that's purely because of this tone. I would say 80% of it is the tone arm. The fact that the sound and the background is darker, the instruments stand out, is to do with the structure of the platter, bearing, partly with the tone arm, etc. So there are different parts of the system play different roles. It's almost like trying to design a Formula One car. It's not just the power of the engine. You can have the most powerful engine and lose every race. It's the aerodynamics, it's the suspension, it's the energy recovering, it's how the center of gravity of the driver and the car and the road that is on all interact with each other. And it's not actually that dissimilar to this. The amount of momentum transfer that goes between the vinyl and the diamond cantilever is colossal. We were talking at lunchtime, if there was no record, there was no vinyl, there was no record player, if any audio engineer today came up with the idea, oh, I know how to store music, we cut it in a piece of plastic and we play it with a tiny little diamond, everybody would certify him as lunatic. He said, this guy is an idiot. He has no, how can you have on a piece of plastic? This has got like dynamic range like this. The bandwidth is huge. And you want to put it on a piece of plastic? Well, there it is. It's not a miracle that it works, but really it shouldn't work, but it does. And vinyl ultimately is the best, currently in this point in time, is the best medium for stored music. Even I have got albums, one of the sort of demos that we do a lot, we're not doing here, is to play actually, as I said, the digital file through the DA converter that is in, for example, Meisel's studio in Abbey Road, using the same mains cable on the DA converter, everything the same. So the output from that is identical to what went into his cutting lathe. We cut the lacquer, send the lacquer to the pressing plant, they metallize it, make the first father or whatever they call it. From that, they make the mother, and then from that, they make the stamper that stamps the vinyl. And I can play the vinyl even on a DG, but with a Mystic, not Magneto. Mystic has got flat response. This doesn't quite have a flat frequency response. Even with a Mystic on a DG, we can play the signal that went into the lathe, play the LP, not an acetate, LP, and not only they're so close, in many respects, the LP actually sounds better. And sometimes you think to yourself, how can that be? This is the source that cut the record. How can this sound in some ways better than this? Not in resolution, not in full dynamic range, but it does sound better. And one of the reasons for it is that when you're listening back to a digital source, even if that digital source was used to cut the record, the playback of the digital has to go through some digital system. It has to be a streamer, a CD player, a computer, or whatever. And then it's got to be converted to analog. You can't listen to the digital. So there is a DA converter somewhere. All of these digital products, however good they may be, they actually have enormous amount of high frequency signature. And you know that because even if we are going to sell this, we have to send it for EMC. It will go there to check all the high frequency contents. Not that of the unit coming out, but how does it get affected by other things going in? And if you look at the EMC test, they've got like a step pass. So anything below this, you can sell. Now, if you got something that is fully analog, the noise is somewhere down here. You have something digital, the noise is then it goes up and it goes up like that. And every peak that goes above this, you have to put some filter, some choke, something to get it to pass so you can sell it. So if you imagine I'm listening to the source that cut the record, but I'm listening through a computer, a DA converter or whatever, all those little high frequency megahertz, gigahertz noises are all there. Now I send that signal into the lathe, and the lathe is cutting the lacquer. Well, the best lathe that actually I believe Miles has got, half-speed cutting, he can probably represent something around 100, maybe 120K, but at a very low level. The lathe is incapable of cutting in megahertz. So suddenly, when you play back the record, none of those noises are there anymore. It's not that you've improved the signal. As I said, your damage control is a bit better. Yeah? So playing something that we haven't actually played this here, but I like to play this for you because I got this just the night before I was coming here to going to Singapore. Aha, there it is. Long time ago, probably about 8 years ago, Miles cut a 45 RPM of Queen's Bo-Rap. And he brought it to our place, we listened to it, and it was unbelievable, this piece that he cut. But I've had that, I've probably got it here. I've had it for 7, 8 years and played it everywhere. Then the night before I was coming here, he came over to go and have a dinner or something, and he put his hand in his bag and he brought this out. He said, I've got this one for you. He cut this one now from his latest upgraded lathe. All the settings are the same. The settings, you know, how you do all the cutting to all the signals, everything going to the lathe is exactly the same. It's just that his lathe has got now slightly better spec. Basically, the biggest difference, the V cards in there have been upgraded. And the V cards on a lathe is almost like the phono stage in your system, if you think of it that way. Yeah. So this is the acetate of Bohemian Rhapsody. I hope you like Queen.
Yeah.
Okay, we play this as long as you promise when the thing comes, everybody starts going like that.
Is this the real life? Is this just fantasy?
A little different, huh? Crazy dynamics. I mean, the kick drum, you can hear you feel the air that is coming from the kick drum, you know. But anyway, we are here, we got material, we can play, we can talk, discuss. But I thought if I make a sort of like a finish here at this point, but not the real finish, then I leave it to you guys. You tell me what you want to know. What do you want to listen to something? Do you want to discuss something? Is there something I missed out? You know, whatever it is.
I have a question.
Yes.
Why your player is the platter is not substantial? It's not substantial as the other. That's so thin of your platter.
Okay. Did every one of you here when we were playing we played the Hugh Laurie on this, didn't we? Anyway, we played some piano on this. Yeah. Did you hear actually any instability? There isn't, and it's not. The energy you take from the vinyl is the drive that comes in. It comes from the drive that you're putting in. Now, you have many ways of trying to keep the speed constant. The best way of keeping the speed constant is through inertia. The inertia needs to be high enough to get the speed going. But no platter can be floating in air. It needs to be somehow supported. It's not correct to float the platter. Full stop. Anybody tells you otherwise, they're mistaken. And this is not an opinion, it's a fact. Because what the diamond is doing is like measuring the groove with respect to time. So all these movements is no different than if you give a piece of ground aluminium or steel to a super precision company and say to them, I want you to measure the surface of this, how much modulation is on the surface. You give it to them and you tell them, but I want you to float it on air. He will just tell you, there's the door, bye-bye. You cannot measure something properly if it keeps floating about. It needs to have some index. And your measuring equipment, which is the arm coming to the cartridge, needs to have the same index to the bearing and the platter. And because you need to support the platter, the bearing is under huge strain and stress. So if I, for no reason, if I multiply the weight of this platter by 5, I put 5 times the pressure on the bearing. So the bearing needs to be designed differently. And the minute you get that bearing running, this, that, the other, you think, okay, I've got 5 times the platter weight. So how do I put the energy in there? So your motor requirements become different. So if you start making the motor even more substantial, then your drive system, the belt or something you're using, needs to also deal with this new torque and energy. Yeah? And if you start making the drive belt stiffer and stiffer and stiffer, almost like to the point where you've got like a solid, like a string going around, then as the platter is rotating and the motor is rotating constantly, there is always a difference between what the platter speed should be relative to this. So it's like a bicycle. When you're paddling on the bicycle, the chain is always becoming a little bit slack, getting taut, slack, getting taut. Now this system of driving the platter will put a kind of a discontinuous force onto the platter. So it's constantly pulling, constantly going like this. Whereas what you want is a continuous one. So if you look at the whole drive mechanism and the source of energy, what you want to do is imagine you have a big tank of water. On the top, you have a little pump, which is the motor, putting enough water in there so that the level of water never changes, never goes higher than this, but doesn't go lower than that. And at the bottom, which is your stylus there, when you open, it's very smooth, the flow of water. If you take the tank off, for example, and have something, so you have absolutely no inertia, yeah, and you put the motor, then it's like opening the tap on the pump. So you get, water coming like this. So it's a balance between how much stress is on my bearing, do I have enough inertia to make sure that the energy that I'm extracting does not affect the speed of the platter dynamically, not statically. Of course, statically, you always, if you have no motor and you put the stylus down, the whole thing will come to a halt. But if you imagine a cartridge, say moving magnet, 5 millivolts at 1 kilohertz, yeah? Even if you say this thing is 30% efficient, you can work out how much power you're actually extracting. These motors that we use, they're 24-volt AC synchronous motors. I don't even run them at 24 volts. They run between 16.8 and 18.5 because I don't need more than that energy in the system. If I've got more, it's almost like putting your foot on the accelerator but half clutching. You're going at that speed, but the engine is just killing itself. Because the more power, energy, you can't kill energy. You can change its form. It can go from, it can change into heat, for example. It can change into sound. It can change its form, but the amount remains always the same. So ideally, I would actually like even less energy than this to drive the system. I don't need much more. And if 1.4 kilograms of platter is not causing any substantial perceived pitch problems, why should do I have something against the bearing? I want to destroy this bearing. I want to put a lot of weight on it. That's one of the reasons why you find if you increase the mass too much, you have to pump air or something underneath it. Because otherwise the bearing just comes to a halt. But you don't need that. I mean, if you look at even the most smooth V12 Jaguar that everybody used to say is the smoothest engine run, if you looked at the flywheel, it was that thick, about that diameter. They didn't put a big grinding stone in the middle of the car. Because you have to also remember, something that is difficult to slow down is also as difficult to speed up. So when the differential between the speed of the platter and the motor changes, if it is more difficult to slow it down, it's also more difficult to speed it up. So your belt starts getting more and more stretched and backwards and forwards and backwards and forwards. All of this basically is a balance. Is not, you can't take one parameter and make it so high and then the other parameter stay at this level. You know, so that's one of the reasons. I don't look at, oh, what should the weight of the platter be? We just look at the construction of the bearing, construction of the motor, the belt drive that we have, and then we decide, okay, this is the amount of inertia we need to represent this kind of stability. And then that will give us the weight of the platter.
Thank you.
Thank you very much.
Thank you,
Thank you. Thank you.
everybody coming.
Thank you. Thank you.